All right, our last problem is number 37. Read the word problem, and what you'll need to do is set it up as 0.45x equal to 90, and I will let you solve that. Have a safe weekend. Please get your math vocabulary done and have these 2 assignments ready to turn in on Tuesday. And I will see you on the Zoom link. Have a good weekend. Bye-bye. Okay. Hey, Gracie, it's Miss Van. I am going to make a video for you to go over 4.6 and 4.7 for your math so that in case we don't have enough time tomorrow, you can still work on that over the break. Just a reminder that I do expect you to have that Chapter 5 vocabulary for math done before you come back to school next week, okay? It's a test grade and you need to get it done and over with. Okay, 4.6. You were assigned number 9 through 30, multiples of 3, and this is in your book. I would encourage you to look along in the book, okay, so that you understand what's happening, because you will get tested on this. All right, we'll start with number 9, and you are working on solving equations with absolute value. So anything that's inside of these blocks, what they're asking is how far this number is from 0. Okay, that's why it never comes out negative. For this, if you have a variable inside of your absolute value, okay, so when, I'm sorry, I might be repeating this, I had to pause you. If you have a variable on the inside, we don't know what it is, so it could be positive or negative, so we put in a couple of options here. We're going to say that we could have a positive or we could have a negative. So we're going to solve for either option. Over here, I want to get y by itself, so I'm just going to divide by that 3. Cancel, cancel, and y is going to be equal to 3 dividing into 12 4 times, and 3 dividing into 9 3 times. Next up, we'll do the same thing on this side, divide by 3, cancels on the left, and y will be equal to a negative 443. When you write this answer, showing all your work, it's going to look like y is, gosh, how did I write this? Hang on one second. It's plus or minus 43. Yeah, y is equal to plus or minus 43. There we go. So you'll just write it in one spot like this. Okay, number 12. Change colors. All right, this time we have x minus 8. Absolute value equal to 14. We're going to set up our problems just like we did for number 9. We'll have x minus 8 is equal to 14, and x minus 8 is equal to negative 14. On this, in order to get x by itself, I'm going to add 8 to both sides, which will cancel on the left, leaving me with 11 is equal to 14 plus 8, which is 22. On this side, I'm also going to add 8 to both sides, canceling on the left. Then I'm left with 11 is equal to a negative 14 plus 8. Remember that when we are adding digits with this different signs, we're going to subtract them, which will leave us with 6, and we will keep the sign of the bigger number. All right, these are your answers. Don't forget to show your work. Here we go, number 15. Is the absolute value of x plus 1 plus 2 is equal to 8. All right, now if you have something outside of the absolute value box, we want to go ahead and take care of that before we come up with our plus and negative option. So I'm going to go ahead and subtract 2 on both sides, moving that over. Canceling here, I'll be left with the absolute value of x plus 1. Close that is equal to 6. Okay, now we're ready to write our options. So we have x plus 1 is equal to positive 6, and x plus 1 is equal to negative 6. I'll cancel my 1 over here. Leaving me with x is equal to 6 minus 1 is 5. On this side, I'm going to go ahead and subtract again. Cancel. X is equal to negative 6 minus 1. Remember, we will keep change there, and we'll have negative 7. By the way, I assume you already understand this, but if I do need you to not share this video with any of your friends, even if you mean well, because they are not lab students, and this is a service that is just for you, okay? And I'm trusting you with that, so please go ahead and keep the video to yourself. All right, let's see, number 18. Also, I should have said this at the beginning of the video, but don't forget that I'm working at a pretty fast pace to get done, but you have the option to pause this video at any time so that you can catch up, okay? You can also go back and replay parts, so don't feel stressed out while we're running through this. Just use it to your own ability. All right, number 18 is absolute value of 2x minus 3 plus 7 equal to 2. Just like on number 15, I'm going to go ahead, I don't want anything outside the absolute value, so I'm going to subtract 7 on both sides, canceling it here. I'll be left with 2x minus 3 is equal to, all right, I'm subtracting, so I'll keep change. That leaves me with a negative 5. Now, because you have a negative number with your absolute value, this is actually going to be no solution, and you are done with that problem. All right, that is number 18. Let's look at number 21. For this one, they put it a little backwards. We'll have 19 is equal to the absolute value of 12x minus 5. So for this, we'll do the same thing. We're going to come up with a problem that is of 12x minus 5 is equal to 19. 12x minus 5 is equal to negative 19. We'll go ahead and solve here. I want x by itself, so I'm going to go ahead and start with 5 and move it over, canceling it here, leaving me with 12x equal to 24. To get the x by itself from 12, I'm going to divide by it, which will cancel it on the left. Also divide on the right side, which will leave me with x is equal to 2. All right, on the negative side, we'll also add 5 and add 5, leaving me on the left with 12x equal to negative and a positive. I'll subtract, keep the sign of the bigger number, get x by itself by dividing by 12, canceling on the left, and x is equal to negative. Now I need to decide a number that will go into both of these. Definitely 2, right? So that 2 will go into this 7 times and 6 times, so that looks pretty good. Negative 7 sixths. Okay. Answer. All right, number 24. It's x minus 1.2. Close that absolute value. Move this. Minus 2 is equal to 11. Again, anything, remember this is your absolute value bar. They get a little confusing with just with 1, they look like 1 sometimes. I'm going to go ahead and move that 2 over, get it out of the way, which will leave me with the absolute value of x minus 1.2 equals 13. All right, let's go ahead and set that up as x minus 1.2 equal to 13, and x minus 1.2 is equal to negative 13. All right, in here I'm going to go ahead and get the x by itself by adding 1.2 here to cancel, and then adding it on the right. X will then be equal to 13 plus 1.2 is 14.2. On this side, I'm going to go ahead and I'm going to add 1.2 to both sides, which will cancel me on the left, and I'll have 11. X is equal to, I've got negative 13 plus 1.2. So if I'm adding signs with different, if I'm adding numbers with different signs, I'm going to subtract and keep the sign of the bigger number. So if I take 1 away from 13, I'll have 12, but I have to deal with the 2. So I'm going to have 11.8 on this side. All right. And those are your answers. For number 27, they give you a problem where they want you to go ahead and write these kinds of absolute values. And this one says they want you to show an equation that is 4 units from 2. All right, now the word from means like how far from it, so we're going to think of that as subtraction. And we're coming from 2, so the 2 is what I'm going to put inside my absolute value. Because I'm coming from it, I'm going to make it subtraction. And where I am going is the 4 units. So we're going to put the units on the other side of the equal sign, and the last half will be our absolute value. Okay, so for number 30, that problem says 5 units from 15. Okay, that is also minus. So I'm going to go ahead and let you use this example and finish up that problem yourself. Okay. The last problem that you have is number 37. Now on this one, they have given you a formula, and it's an annual percentage rate, and it looks like 1 plus your APR, your annual percentage rate. That could be on anything like a loan, a credit card, any kind of money that you have borrowed. All right, over n to the nth power minus 1. Now the n is your terms, so that might be like if it's an annual percentage rate, if it's annual once a year, then n might be 1. You could also have a compounded loan where maybe it charges you interest every day, daily. So n might be 365. It could be, quarterly, where it charges you 4 times a year, that kind of thing. But wherever they're charging that interest is where you're going to put this money. So on number 37, they give you a problem, and what they want to know is which is going to charge, which is going to give you higher interest rate. So on this one, really you're thinking of, you want the higher rate because if this was a savings account and they give you, depending on the terms, then that's how much money you would gain in interest. So your first option is a 6% simple loan, which means it's going to apply annually. So what we're going to do is we're going to plug in our numbers. We'll have 1 plus your APR. Now your term is just going to be 1 because it's annual, which means we're going to put you at the power of 1 to the power of 1 minus 1. And whoops. So instead, let me go back, go ahead and erase here. where it says APR, I want you to put 6%. Now we always move our percentages to a decimal if we're going to use them mathematically. So if you're at the percentage rate, remember, you're going to go 2 to the left to land in the decimal. Okay, so if I have 6%, my decimal starts right here on this side. I'm going to move over 2 spaces. There's 1, there's 2, and so the decimal I'm using is 0.06. Okay, so what we'll do now, this one is pretty simple. I'm going to use, I like the big mama here. Let me clear it out. I'm going to punch the whole thing in. All right, so I have 1 plus, I'm just going to punch in everything that we have here, 0.06 divided by 1. Close that and put it to the power of 1. Bring it down and say minus 1. Okay, and when I hit that, I end up with 0.06. Okay, that means when I move it now from a decimal to a percentage, I'm going to move it back over 1, 2. That means I'm going to earn 6% back. Okay, now we're going to compare that problem with, let me change colors, a 5% compound. You don't have to write these, by the way. And it's going to be compounded quarterly. All right, so we'll plug this in at 1 plus, again, 5%. Move it over 1, 2, which puts me at 0.05, divided by my terms. Now, quarterly means fourths, right? 1 quarter, 2 quarters, 3 quarters, 4 quarters. So I'm going to put that in as a 4. That means every quarter, every 3 months, it will compound your interest. And of course, I'm going to put my exponent as the same, minus 1. So for this one, we're going to walk over, and I was thinking about letting me redo, but it's not. Okay, so let's clear this. Clear. I'm going to hit clear a little bit more. That's weird. Okay, so we'll have 1 plus 0.05 divided by 4, okay, to the 4th power, minus 1. All right, so that leaves me with 0.05. I'm just going to stop at the 9, okay? Again, if I have a decimal and I want to know what the percentage is, I'm going to move 2 to the right. So I'm going to go 1, 2 there, and I'll have 5.09%. So at this point, you're trying to decide which, this loan is definitely better, right? Which is better? You want to earn 6% or 5.09%. So you'll have this answer and this answer, and you'll say, you know, largest, larger, whatever, okay? These are your 2 answers. Now, let's move over to 4.7. I'm going to go ahead and start fresh with some paper here. All right, in 4.7, we're doing problems 9 through 27. She said to omit number 24. And then she wants to see 34 through 37. All right, so we'll start with number 9. Still dealing with absolute values here, Gracie, but we are going to use inequalities now. And those are the less than, greater than or equal to, you know the drill. Okay, you've seen them before. So I have the same absolute value, the same rules, only this time I'm dealing with symbols instead of equal sign. We're going to do the same thing that we've been doing. We're going to take the 2x plus 6 greater than or equal to a positive 14, but I need a negative 14. So I'm going to say 2x plus 6 less than or equal to a negative 14. So notice when I did the negative, I swapped my sign. Okay? All right, let's go ahead and solve. So I'm going to try to get x by itself. I'll move 6 over here and cancel on this side. That leaves me with 2x greater than or equal to 14 minus 6, which is 8. Now, in order to get x by itself, I need to take that 2 and divide because they are multiplying. Got to do the opposite. Canceling those should leave me with x greater than or equal to 4. All right, let's take care of the negative side. I'm going to subtract over here as well. Canceling on that side, leaving me with 2x less than or equal to, now I have a negative 14 minus 6, so remember we keep, change. That means that I am adding negative 14 plus negative 20, which is going to give me a negative 6, which is going to give me a negative 20. I need x by itself. Again, I'm going to do the opposite and divide by 2. Those will cancel on my left side, leaving me with x less than or equal to negative 10. So one thing that they want to see on this is graphing. So we're going to give the people what they want. All right, go ahead and we're just going to do a simple line. You just really need the numbers for your answers. So I'm just going to put a negative 10 here. And here's my positive 4. Let's put a 0 in the middle. Okay, and then we'll show what this graph says. This one says that x is greater than or equal to number 4. So remember, if it's underlined, we get to close. We get to close that because it includes 4. And greater than, I'm going to follow that arrow. So that I am now going in this direction. For the negative 10, it's also going to be closed. And this says that y is less than or equal to, which means that this is going to be moving over into the opposite direction. That means that these are not, this is not a conjunction. They are separate, so it is a disjunction. So I am going to write my problem as x less than or equal to negative 10 or x greater than or equal to 14. And that in your graph is your answer. Remember to list the small side first. Okay, let's move on to number 12. Absolute value of 2/3 x minus 7 is less than or equal to a 4. Move this up a little bit. All right, so we'll set that up as 2/3 x minus 7 less than or equal to 4. And I'm going to move it down here a little bit because I want room. So 2/3 x minus 7. Remember to swap that sign. Greater than or equal to a negative 4. Okay. To get x by itself, I'm going to start with the 7, adding it on both sides. These cancel here, and we're left with 2/3 x less than or equal to 11. Now, with fractions, in any other circumstances, any other number, this 2/3 x means that they're multiplying each other. So I should divide by the fraction in order to cancel it and move it. However, there is a rule that says I can take the reciprocal or the flip-flop option of it, right? And I can multiply both sides with that. So 3 and 3 cancel, 2 and 2 cancel, and you're left with x less than or equal to 11 times 3 halves. So I'm going to think of 11 as 11 over 1, and with fractions I can just multiply straight across. 11 times 3 is 33, and 1 times 2 is 2. So this is my first answer. Okay, the negative, we're going to use the same way. Let's move that 7 out of the way. Canceling here. I'll have 2/3 x greater than or equal to negative 4 plus 7. When I'm adding numbers with different signs, I'm going to subtract them and keep the sign of the bigger number. Just like I did up here, I am going to multiply these fractions by the reciprocal on both sides. Okay, sorry about that. So we're multiplying by the reciprocal. Remember, we're going to think of this 3 like 3 over 1. And I'll be left with x greater than or equal to, multiplying straight across, I have 3 times 3 is 9, and 1 times 2 is 2. All right, so when I look at graphing this, and I'll be real honest, the conjunction, disjunction, I know there's some kind of rule to it, but I have a hard time picturing it in my mind. So one thing that I do is, like if I have something like this, I'll kind of say, okay, 9 divided by 2 is about 4-ish, right? So I know I have a 4 somewhere. And then over here, when I look at 33 divided by 2, that would be about 15 or 16. So I know I've got like a positive 15-ish over here and about a 4 over here. Here's 0. So I'm going to go ahead and just kind of graph what that would look like, which they also want you to do on this problem. So for this, for the 15, I have x is less than or equal to the 33 halves. So I've got less than or equal to, which means I can close it because it's equal to that. And it's less. So it's going to follow the arrow in this direction to the left. For the second problem here, x is greater than or equal to 9 halves, or 4 as we're calling it. So it's also closed because it's equal to, and it's going to go in this direction. So if I look at this, it does not make a connection. Oh my gosh, I just realized this is completely wrong. Okay, so 4 would come before 15. So let me do that again. I have x is, let's start with the 4. X is greater than or equal to 9 halves, or 4, as we're calling it. So we're going to close that. It's greater than or equal to, so I'm going to follow my arrow here into the direction on the right. Looking at x less than or equal to, I'm going to close that one as well, 33 halves, or 15. Less than would be in this direction. So this, your graph will actually look like this. Let's get rid of this. It'll look like this, which means it is a conjunction and it is connected. When this happens, your answer will have your x in the middle and your smallest number on the left and the larger number on the right. So we'll have x is greater than or equal to 9 halves. So make sure, again, that your sign is open to the x, so it needs to be open over here. We're going to flip it. I'm going to put 9 halves on the half on this side. And for this problem, it's less than or equal to 33 halves. So we'll just get to copy it straight from here. And this is your final answer, showing that it is conjunction and connected. All right, moving on to number 15. Absolute value of 4x minus 7 is greater than or equal to 29. All right, same old same. I've got 4x minus 7 greater than or equal to 29. And 4x minus 7 is less than and equal to 29. Okay, I am going to get you started here. We're going to add 7, and cancel. And I want you to go ahead and finish this problem by yourself, okay? Solve for x on both sides using the examples. You do go ahead and make a graph based on your answers. I will give you a hint and tell you that in the end, you're going to use OR, okay? So your final answer is going to be this problem or this problem. So remember, you'll do smallest on the left and largest on the right. Whoops, let me see. All right, so you'll have the smallest number on the left, and it'll say or the largest on the right. So this will look like x greater than or equal to whatever you end up here. Whatever these two end up being, plug them in right here, okay? So that is number 15. Let's get you started on number 18. The absolute value of 4x minus 6 is less than 72. All right, this one is pretty straightforward as well, so I'm going to rewrite it here. It's a positive 72, and swap the sign for a negative 72. When I add 6 to both sides, I'm left with 4x less than 78. And on this side, I'll add 6 and add 6, and I'll be left with 4x greater than negative 72 plus 6. So I have different signs. I'm going to subtract and keep the sign of the bigger number, which will leave me with 66, I believe, negative 66. Oh, shoot fire. Okay, ignore this. I just found another mistake I made, so let me restart number 18. I'm not going to fix my video, sorry, but I'll try to remember to add a note. Let me make it 4.7, number 18, restart. Okay, I'll try to warn you in the email about this. This does have a number on the outside. It has a 3. Absolute value of 4x minus 6 is less than 72. So like we've done in the past, you're going to want to take that 3 and move it over. Now, if it's right next to the absolute value, remember the only thing that can be nestled up, snug as a bug to something, it means multiplication. So I'm going to take this and divide by 3. And what I do to one side, I do to the other. We'll cancel here. And you'll have absolute value of 4x minus 6 is less than 72 divided by 3. 3 will go into 7 twice with 1 left over, and 3 goes into 12 4 times. So now we'll rewrite 4x minus 6 less than 24 and 4x minus 6 greater than negative 24. Okay, let's solve these by adding 6 on both sides here. Remember, our goal is to get that x by itself. This will be 4x less than 30. I'm going to add 6 on this side, canceling on the left, leaving me with 4x greater than negative 24 plus 6. I'm going to go ahead and subtract again because I have different signs. Negative 24 plus 6 will leave me with negative 18. And I can get rid of 4 on both sides by dividing. Canceling. And then I'm going to leave you to write what the answer is. Okay. If you have improper fractions, I'll show you on this one. You're going to want to leave them there. So if I have 30 divided by 4, 4 will not go into 30 evenly. So I'm going to go ahead, I'm going to divide both by 2, which will give me 15 halves. Okay, and I'm going to leave that as my answer. So these will also divide by 2, so go ahead and reduce them. And that will be your answer here. I will tell you that this problem is a conjunction. So you're going to put your smaller number on the left, especially if you have any kind of negative numbers, okay? And then you'll have your larger problem over here. So I will tell you, you'll put the 15 halves on this side, and then you'll put your smaller, oops, sorry about that. You'll put your smaller number on this side. And I'll let you fill that one in from here. Okay, and this is your final answer. I'm going to pull up a little bit here, and let's look at number 21. So like we did on 4.6, this is similar. It says that it gives you a situation where you need 2 units from 5. Remember, if it says from 5, it's going to be subtract. The end goes at the beginning, so the 5 is going to go inside my absolute value. It's from, so I'm going to subtract. And 2 is my destination. Okay? However, here you want to, it's asking for an inequality. So what it says is no more than 2 units from 5. So if it's no more than, that means it can't be bigger than 2, right? Whatever this number is cannot be bigger than 2, but it can equal it. All right, and that will be our answer there. Number 24 was omitted, which leaves us with 27. I'll walk you through this one too, because it's a little difficult. This word problem tells us that they want to understand how many minutes they have. If they have to be within 30 minutes with no more than a 3-minute difference, okay? So it would be 3 minutes from their 30 minutes. So again, if it's from 30, I am going to make that subtract. So it'll be absolute value of x minus 30. And it said no more than. So it can be less than 3, but it cannot be greater than. However, it can equal 3, no more than 3. So we're going to make it less than or equal to. And we are going to solve this one, so I'm going to set it up over here. X minus 30. Oh, you know what? Yeah, just leave it x. X minus 30 less than or equal to 3. X minus 30, switch your sign, greater than or equal to negative 3. To get x by itself, we'll add 30 on both sides. Canceling here. X is less than or equal to 33. Adding 30 and adding 30. Canceling on this side, x is greater than or equal to, these will cancel, and I'll have 27. So for your answer, you'll take the smaller number, and it'll be 27 less than or equal to x less than or equal to 33. So it can be, if you have 3 minutes within 30 minutes, would it be at 27 minutes or 33 minutes? And that's your final answer for that one. Went ahead and did that for you, but you know. Number 30. What number was this? All right, so now we're doing 34 through 37. So I'll get those started for you as well. For this one, they gave you 2/3 x equal to a plus 6. Okay? And what they want you to do is to solve for x. They want x by itself. So remember, we talked about moving that fraction over without dividing. We multiply by the reciprocal. So I flip-flop it, and these cancel and these cancel. You'll be left with x is equal to all of this multiplied by 3/2. So I'll have 6 times 3/2, but I'll also have a times 3/2. On this one, I'm just going to leave it as 3/2 a plus, I've got 6 over 1. 6 times 3 is 18 divided by 2. Now we can reduce that, saying 18 divided by 2 is 9. So let's rewrite that one more time. x is equal to 3/2 a plus 9. Okay, same thing with number 35. This one said 4x plus b is equal to 2c. Again, we want to solve for x, which means we want it all by itself. So we're going to subtract b on each side. Canceling over here, we'll have 4x is equal to 2c minus b. In order to get x by itself on this side, I'm going to divide both sides by 4. Canceling, x will be equal to 2c minus b divided by 4. The end. For number 36, so for number 36, they have a product that went from 80 to 100, and they want to know what the rate of change was for that. So what you want to do when you're dealing with this and you're trying to figure out the percentage difference between 80 and 100 is you want to put the amount of change and you want to divide it by the original number. Okay? So 80 to 100 means it went up 20, right? I'm going to put that right on top. It's changed by 20 plus 20, and it was originally 80. So from here, I can say, I could just take out my calculator here and say 20 divided by 80 gives me 0.25. And we know that I want a percentage, right? That's what it asked for. So again, with my Dr. Pepper, if I'm at a decimal and I want a percentage, I move over 1, 2 places. So I'm going to move that decimal 1, 2, which puts me at 25%. All right, don't forget to show all your work. And our last problem is number 37. Let's make sure